Hello, everybody. Welcome to Major Mass Clubhouse. I'm Michael, and I'm your host. So during our last episode, we were dealing with salt. We did some little problem solving. Um, but this episode, we're going to be doing a little of an introduction, to salt, and I'm also going to be introducing you to the rules guiding salt, so that during our subsequent episodes, um, you have a proper understanding of it. But I promise you, by the end of this section, you have a basic to an intermediate understanding of what salt is. All right, so let's commence. So, what is salt? There are a lot of definition of salt. Um, you could say salt is an irrational number in a root form. That's what an advanced student will say. A basic student will say salt is a number with no root. Then maybe Gen Z student, Gen Z student might just say sorts are those weird looking square root that don't simplify perfectly. So yeah, so what is sort? Sort are first thing first. Uh, what are sorts? Sorts are first thing first. Irrational numbers. Sorts are irrational numbers. Um, in its root form. In its root form. So this is what it means to say in its root form. Um, So before I commence into types of sorts, let me just explain a little thing. So usually numbers are broken down. There are several categories of numbers, but in this case, numbers are broken down into two categories: rational and irrational. So what are rational numbers? Rational numbers are numbers that can be expressed in a fraction. So when I mean expressed in a fraction, A over B or P over Q. So examples of rational numbers we have is numbers like 2 because they can be expressed as 2 over 1, or numbers like minus 3 because they can be expressed as minus 3 over 1, or even numbers as 2 over 4, which is 1 over 2, or 3 over 5. All these are rational numbers because they can be expressed as a fraction. For irrational numbers, so we have root 2, root 3, pi. Yeah, there's something we call golden ratio. So all these are irrational numbers. So please take note. When you have 1 over 3, this 1 over 3 is not an irrational number because it has a recurring pattern. So we have 1 over 3 is equals to what? 0.3333. It's recurring. It's repeating. When I mean recurring, it's repeating. Meanwhile, for something like pi, for something like okay, good. Pi is what? 3.14159.265. And it continues with no pattern. There's no definite pattern. You understand? So same thing with 2 over 3. We always give you 0.6666. So this is a rational number. Why this is an irrational number? So irrational number in terms of fraction are fractions that are either terminate. So when I mean terminate is something like this. 2 over 5 will give you 0.4. The end. And stop. So that's what we call terminate. To terminate to end. Or 4 over 5, what's it? 0.8. So that's what we call terminate. So yeah, that's that. We're going to be dealing with types of salts. Um, so we have pure salts. We have mixed salts, and we have compound salts. So pure salts are salts like root 2, root 3, root 31, root 5, root 7. No accompanying coefficient, no accompanying figure or digits. Yeah, 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 yeah. Also, take note, pure salts can also be the cube root of 7, the fourth root of 11. Yeah. Basically, the n root of any number. All these are pure salts. Meanwhile, for mixed salts, we have 3 root 2, 5 root 3, um, 6 root, sorry, 6 root 7. We have 3 root 7. We have 4 root 11, and n root x. So I intentionally brought this, so you can see that's an accompanying coefficient, accompanying integers, that's accompanying numbers. So now you can see the difference between this and this. The tree is stuck in between here. So when here is stuck in between here, it becomes a root. But when it's here, it becomes a whole number. So there's a difference. This is the third root of 7 or cube of 7. Why this is 3 root 7. So same thing goes for here. Fourth root 11 and 4 4 fourth root 11 and 4 root um, 11. Then n root x for this. Why this is n nth root x. Nth root of x. Fourth root of 11. 4 root 11. Fourth root of 11. Third root of 7. 3 root 7. So you can see the difference now. Alright, so for compound, we have 3 plus root 2. We have root 3 plus root 2. We have 2 root 5 plus 6 root 7. We have, and no, you can also say root 7 minus root 2. All these are compound salts. So they are just basically roots that has a sign, a plus sign or minus sign with either root, either accompanying root or a whole number, depending. So that's that for sorts. So up next, we're going to be dealing with rules of sorts. So it's addition. We're going to commence with addition. So to say um, root A plus root B is not equals to root A plus B. So what it means is that you can't say what it means basically is, let me give an example. E.g., you can't say root 2 plus root 3. You can't say it's equals to root 2 plus 3, which is what? Root 5. Nah, nah. So basically, you can't say, in other words, you can't say root 2 plus root 3 is equals to root 5. Nah. You can't say that. So alternatively, you can say something like A root B plus C root B is equals to uh, bracket A plus C root B. You can basically see that they have the same sort. They have the same base root. Yeah, we call this basically we call this a base root. So you can see that they have the same base root, right? So alternatively, like example, let me give you an example. An example could be um, 3 root 2 plus 5 root 2 should give you what? 3 plus 5 root 2, which is equals to 8 root 2. So that's it. There you have it. Anyway, in our subsequent videos, I'll be doing more problems on this. So, but I'm just basically trying to explain the rules here. Yeah. So up next is subtraction. So we have for subtraction, um, okay, so similar to the addition rule, you can say root A minus root B is not equals to root A minus B. E.g., e.g., let me give root 5 minus root 3 is so not equals to um 5 minus 3, which is what? Root 2. So similarly to the ones we previously did in addition, we can say B root A minus C root A is equals to bracket. You know what your bracket is now? Bracket means multiplication. Since this literally means B times root A. So bracket means multiplication. So you say B minus C in bracket root A. So an example is let's give a quickie here. An example, okay, is 10 root 3 minus let's say 7 root 3. What will it give you? We put in brackets uh 10 minus 7 root 3. We should give 10 minus 7 is what? 3 root 3. So that's that for subtraction. So for multiplication, it's totally different here from here now. So it's totally different. So you have what? Root A times root B. It's not equals to, nah, it's equals to your dreams. Yeah, it's equals to A times B. You thought I was going to put not equals to here. Nah. So root A times root B is equals to root A times B. So example, I've been given a lot of trays and tools. So let's do something different. So root 7 times root 5 will give you root 7 times 5, which should give you what? 7 times 5 is what? Root 35. So like the way we did the previous one, we could say A root B times C root D will be giving you A times C bracket square root B times D. So which is what? AC square root BD. BD. So an example is an example. Okay. So let's give an example of maybe 4 root 7 times 5 root 3. Yeah. So this gives you what? Like following this rule, we'll say 4 times 5 in brackets root 7 times 3. So 4 times 5 is what? 20 root 7 times 3 is what? 21. So up next, division. So now we have division. So similar to the way we did multiplication, we could say root A over root B. We could also say we could also say n root of A over n root, as long as n root of B, as long as they have the same power. You could also say that is equals to what? Um, root A over B. Please always remember it doesn't have to be just square root. It can be any root, any figure. If as long as there's seven roots here and there's seven roots here, these rules can go as well as the other rules. Alright, so similarly we have um okay, then let me give you an example. So I'm giving an example as hmm, okay. Let me give you an example as root 21 over root 7, which is equal to what? Root 21 over 7, which will give you what? Root 3. So similarly like what we did in the previous, you can say A root B over C root D will give you A over C times B over D. That's what um, A over C root B over D. So an example, a classic example could be if I say um, 6 root 8 over 3 root 2. Yeah. So if you say using this tool, you say 6 over 3 times root 8 over 2. So 3 going to 3 1, 3 going to 6 2, 2 going to 2 1, 2 going to 8 4, which is going to give you 2 root 4. Of course, 4 is a square root, so you can say equals to 2, 2 root 4 is what? 2 times 2, which is equals to 4. So, but of course, we're going to be giving more examples with time in our subsequent sections. So, yeah, that's that. So, um, so that's that about results. But before we round up this section, let me give you some fun facts. Um, did you know that you can express this form as this 2 raised to the power of 1 over 2, or this form as this 2 raised to the power of 1 over 3? Did you know you can express it like this? So basically, what I'm saying is that the n root of x will always be equal to x raised to the power of 1 over n. It can be expressed like this. Um, so did you also know that salt also came from the word sawdust, meaning deaf or silent. So that's what in the ancient Latino, that's what they classified this as. It to be silent because it can't be simplified cleanly. That was usually the word they used, cleanly. And also root came from the word radix, which also means root in ancient Latin. Yeah. So this was called Skundus until a mathematician, I think that should be Roger Bacon, um, changed those ideas to salt. Salt, yeah. So So that's that. So that's it. Hope you had fun on our journey today. So in our next episode, we'll be dealing with more of the operations. That's the addition, the minus, the multiplication, and the division based on the rules we did today. So thank you, everybody. Also, kindly like and subscribe my page and my channels. Thank you. Have a lovely day. Bye bye.